It is 11 at night, and an email arrives. Your package has been delayed. Again, you open a chatbot and type, "Fix this for me." It gives you a beautiful checklist. Find the order number. Read the refund policy. Contact the seller. Ask for a replacement if necessary. Helpful, but you still have to do all the actual work. Now imagine a different system. It finds the order, reads the seller's policy, discovers that the item is out of stock, compares a refund with a replacement, drafts a message, and then stops before submitting the refund to ask, "Should I continue?" The same sentence went in. One system offered advice. The other began moving the situation toward an outcome. That second kind of system is what people mean by an AI agent. But the name creates a dangerous illusion. It sounds like a new kind of AI that is smarter, more independent, perhaps even equipped with a will of its own. The real answer is less mysterious and far more useful. An agent is usually not a brand new brain. It is closer to a language model that has been given a goal, a toolbox, a workbench, and boundaries, then placed inside a loop that keeps asking, "What should happen next?" First, separate three things that are constantly mixed together. A chatbot is like an advisor sitting behind a desk. You ask a question. It gives an answer. Even if that answer contains 10 steps, the chatbot usually has not performed those steps. A traditional automation is more like a conveyor belt. Every move is designed in advance. If the order is late, check inventory. If inventory is empty, send a refund email. It is dependable, but when an unfamiliar obstacle lands on the belt, the system may simply stop. An agent is more like a junior operator with limited permissions. You give it an outcome without hard-coding every move. It inspects the situation, selects a tool, sees what happened, and chooses the next step. The difference is not whether there is a chat box on the screen. It is not whether the product name contains the word agent. The real question is, who controls the route? If software has already chosen every path, you have a workflow. If the model can use the current state to choose a tool, change direction, and decide when the job is complete, you are much closer to an agent. A practical agent can be pictured as 5 connected parts. The first is a goal. Not, say, something useful, but an outcome that can be judged, such as resolve this support ticket. The second is the model. It interprets the goal, reads the current situation, and makes judgments between possible actions. The third part is tools. Search, databases, calendars, code runners, ticket systems, and messaging services can all become tools. A model does not magically open your order database. Ordinary software interfaces are what actually read and changed the outside world. The fourth part is task state, sometimes including memory. It records what has been tried, what the tools returned, and where the task is now. That state might disappear when the job ends. Some systems also store information for later. Long-term memory is useful in certain agents, but it is not a magical requirement shared by every agent. The fifth part is guardrails. They define what the agent may see, what it may change, when it must stop, and which actions require human approval. Put those pieces together, and you get a system that can do more than produce words. It can move through work. Return to the delayed order. The agent reads its goal, solve the problem, but never issue a refund without approval. It chooses a first action and queries the order. The tool returns 2 facts. The package is late, and the item is now out of stock. That result is an observation. It brings the agent back to the decision table. The replacement route is now impossible, so the agent updates its plan. It reads the refund policy, calculates the eligible amount, drafts a message, and reaches a high-risk action, actually submitting the refund. The guardrail stops the loop and asks the user for approval. That is the core pattern. Decide, act, observe, and decide again. Most of an agent's autonomy lives inside this loop. It does not need to know the entire route from the beginning. It needs to choose a reasonable next step from the evidence in front of it. If a tool fails, The agent may retry, choose another tool, narrow the task, or hand control back to a person. This is also why coding agents are such an easy example to understand. An agent can edit code, run a test, observe the failure, and try a repair. A test result is not praise or a vague feeling. It is feedback from the environment. At this point, an agent may sound like a superior version of automation. But more flexible does not always mean better. If a task follows the same route every time, the conveyor belt will usually beat the junior operator. It is faster, cheaper, and easier to audit. Agents become useful when the steps cannot all be known in advance. The input is messy. The system must interpret documents, change direction after new information, or handle exceptions that would turn a rulebook into a maze. That flexibility has a price: more model calls, more waiting, and more uncertainty. Using an agent is not a badge of technical maturity. Sometimes the smartest agent design is realizing that you do not need an agent at all. When a chatbot says something wrong, the mistake usually stays on the screen. When an agent says something wrong, it may call a tool next. That result enters another decision. An early misunderstanding has now put on shoes and started walking. The agent might choose the wrong customer record, send the same message twice, become trapped in a retry loop, or treat malicious instructions hidden inside a web page as part of its real task. Security researchers call that last problem prompt injection. For an agent with tools, outside documents are not only information. They can also contain text that tries to redirect the agent's behavior. This does not mean agents are destined to be dangerous. It means reliability cannot come from one sentence that says, "Please be careful." Tools should have the smallest permissions they need. Outputs should be validated. Retries should have limits. High-risk actions should require approval. And important steps should leave a log, so people can see what the agent observed, which tools it used, and where it stopped. Autonomy is not a switch. It is a slider. Reading public web pages may sit near one end. Sending a draft deserves more caution. Paying money, deleting data, or signing an agreement should stop at a human checkpoint. With a chatbot, we are used to writing prompts. With an agent, we are doing something closer to delegation. Good delegation needs 4 things: a clear outcome, enough context, an approved set of tools, and a stopping condition. Handle my inbox is vague. Group today's customer emails, draft replies, but do not send them, and flag anything involving a refund or a legal threat is much better. Agents do not remove management. They move management away from every individual click and toward goals, permissions, checkpoints, and acceptance criteria. Future agents may run for longer, connect to more systems, and make more decisions between human instructions. That is a reasonable direction, not a single reality that has already arrived. Products still differ enormously in capability, permissions, and reliability. Now return to that delayed order at 11 at night. The chatbot is an advisor. It tells you what to do. The automation is a conveyor belt. It moves along a route built in advance. The agent is a junior operator carrying a toolbox, a work log, and a limited access card. It can choose the next step, but not its own goal. It can use tools, but only the tools you provide. It can continue working, but it must know when to stop and call you. That is the important change behind AI agents. The machine has not suddenly developed a will of its own. We have placed a language model inside a loop designed to finish a job, instead of asking it to produce one answer. And that changes the question from, "What can this AI say?" to something much more consequential. What are we willing to let it do? And who decides when it must stop?